My name is Sheel Sanghvi. I'm a second-year PhD student in the Material Science and Engineering Department at Northwestern University. My research is focused on solid acid fuel cells. These are electrochemical devices for taking a fuel, such as natural gas, and converting it into electrical energy. To frame our problem, let's look at the largest source of pollution in the United States. We produce our fuel by burning fossil fuels. This produces a lot of greenhouse gases, things such as nitrous oxide and carbon dioxide. With the movement of our society with our society becoming more industrialized, we have increased the amount of carbon dioxide we're producing compared to the last couple thousands of years. Now this has a very big impact on our environment. We can see it through three main effects. This increase in greenhouse gases has caused rising sea levels, an increase in global temperatures, and a decrease in Arctic ice. More specific to us, we can see it as a change in climate, more storms, and the extinction of our animals. So the question is how can we stop these changes from happening? How can we stop the effect of greenhouse gases from actually escalating? And the key to stopping the greenhouse gas effect from escalating is to improve our energy generation. The key to improving energy generation is improving efficiency. Our current way of producing efficiency is by using an engine. This is very inefficient because we are burning a fuel, and it has an efficiency of around 40 to 60%. The device that I research, the solid acid fuel cell, has a maximum theoretical efficiency of around 90%. This means that for one drop of a fuel put into a solid acid fuel cell, you can get almost double the energy compared to a regular engine. So what is a solid acid fuel cell? A solid acid fuel cell utilizes principles of electrochemistry. And electrochemistry is a combination of chemical reactions and transport of electric charge. Most commonly, you've probably heard of electrochemistry being used in an electrochemical device, such as a battery. A battery uses chemical reactions to store energy, whereas a solid acid fuel cell uses chemical reactions to produce electricity. More specifically, within a solid acid fuel cell, you can take a fuel, such as hydrogen, combine it with oxygen in the air to produce electricity and water. This is efficient, this is clean, and if a carbon-free fuel is used, the only byproduct from this type of electrochemical reaction is water. Specifically, what's going on in a solid acid fuel cell is that fuel is at the anode and air is at the cathode, and they're separated by the electrolyte. The electrolyte is also known as the solid acid and gives the solid acid fuel cell its name. The electrolyte controls the reaction between the fuel and between the oxygen in the air, allowing us to actually capture the energy. It breaks down the electrochemical reaction into its electron part and its chemical part. The electron part is what powers our devices, and the chemical part is what is part of this reaction. Now, currently, solid acid fuel cells are used in very limited applications. They're used in the military, and they're used in specialized industries. And this is because of one reason. It's because of the electrolyte, because of the solid acid. The electrolyte requires a partial pressure of steam, so a small amount of water vapor in the air to be stable. This dependence on steam actually means that without steam, the solid acid will dehydrate and decompose. So scientists actually have to provide the solid acid fuel cell with steam. This has two negative consequences. Since the solid acid fuel cell has steam, there's a lower efficiency, and reuse of the fuel cell is difficult, limiting the applications in which we see the solid acid fuel cell. The solution to this problem is to make a material that does not depend on steam, so it does not dehydrate it when you heat it up. And this is what the crux of my research focuses on. Can we make a new solid acid that is stable without steam? To do this, my research is broken down into three steps. The first step is, can we actually predict if any solid acid compounds are possible? And we use computer models to generate these predictions. Once we're able to predict if something might exist, the second step is actually to synthesize it, to take something that is only thought about and bring it into the real world. And this is where we step into the chemistry laboratory. The third step is to take the solid acid and to actually test out its properties. And this is done through electrochemical testing to make sure that it has the properties correct for a fuel cell. So what does this mean to me and you? My research on solid acid fuel cells will take it from a limited application and bring it to the home, allowing the benefits of the solid acid fuel cell to be available to everybody. Thank you.